All right, people. Today I'm going to be implementing a quick ring buffer data structure to help us with later on a single producer consumer problem. I'm going to be making this in C, and if I have the free time, I might migrate it to be a class in C++ so that we can just call the read and write methods directly to the class. But that'll just be to up my C++ skills. So this is our ring buffer. It's usually just a simple array with stable pointer mechanics and math to ensure that we wrap around essentially to our starting point. So let's say our starting and end of our data structure both point to our same spot. As a write comes in, let's say it let's do a different color. Let's say it fills this slot. What will happen is the end jumps to here. The start stays at the same spot, and essentially our start is our read pointer, and our end is our write pointer. So as we write something to the buffer, we'll increment end. As we read something from the buffer, we increment start. These kind of define our bounds of available data and make sure that we're accessing data that actually exists and populating in the right locations. Now, skipping a few steps forward, as we populate this whole thing, we're going to need to wrap back to this original, or like this start location right here, let's say. So the way to do that is once we get to a point where our end is here, what we're gonna do is let's say our ends here is going to populate this, and this is where we need to wrap around. So we're gonna pre-check that our end pointer plus 1 is greater than our bounds. And if it is, we'll do a ternary operator here. If it is, then end is going to equal the starting location of the buffer. Start location. I wish I had my iPad on me, but I'm just using a mouse and my iPad's dead. But if it's not the case, then we'll just use this for the buffer update. All right, I think that's enough drawing out. And the same goes for the starting pointer, because these will both wrap around at some point. Now for the actual implementation, we'll open up a C file. And let's just add our includes really quick. What is it? st.io.h. And that should be all we need. So I think first things first is we want to make this ring buffer struct. I'm going to name it RB. And this will have a, let's say we're populating ints. So this will have an int, we'll also define a buffer size. And let's say it's 5, it equals 5. So we'll have an int array called buffer of size buffer size. Now, our we could do a void pointer, but I'm gonna make our buffer start. We'll need 4 pointers here. We'll need the start location of the buffer, which is equal to buffer. We'll need our buffer end, which equals to the buffer plus buffer size. So these are end location of buffer region, start location of buffer region. And then from here, we'll just add our, oh, dang it, I didn't mean to do that, of buffer region. Okay. I gotta change my Vim settings, man. What is going on? All right. Then we'll have our data pointers. So these will be what's, that's what's drawn here. Where's my cursor? Oh. That's what's going to be our start and our end. So we can go back to here. Our data start will be initially equal to buffer start, and same with our data end because nothing's in our buffer to start. Okay, now the first thing I think that makes sense to do is start with the conditions to check if a buffer is full or a buffer is, so a buffer is full or a buffer is empty. So we can start with is empty because this is really easy to figure out. So if you notice how we're declaring this, data start and data end point to the same memory location. What we can do is just have a simple check to return that data start equals data end. That is all we need to do for the empty check. So this would be a condition used with the read functionality, because the way a ring buffer works is it's a LIFO strategy or scheme. So this means last in, first out. So is that true? Let me think about this. We have a start and an end. We'll populate and then we'll read. Let's say we populate 7. The first one in is the last one out. I'm wrong. I knew I was wrong. That didn't make sense to me. So, sorry. A ring buffer is a FIFO strategy. So your first element in is going to be your first element out. So that's why the read will read the value at the start, the data start location. So let's add that here. FIFO behavior. I guess you could do LIFO, but you would flip your data start and data end pointers. But anyway, anywho, sorry for that mix-up. We'll now add in our is full logic. Now this one is a little bit more tricky, but we can do this also in a one-line logic check. Is full. So as I mentioned earlier, if we increment our read or our write pointer by 1 and is at the boundary, we wrap around. So we can write that logic out like so. Let's, not to confuse people, let's not put in the return yet. So we'll take our RB point to data or data end, and we'll add 1 to this for the preemptive check if it's full. And if data end plus 1 is greater than buffer end, then we can then what we return is that RB, sorry, semantics, RB point to data. Oh no, then we'll just return buffer start. And then if that's not the case, if it's not true, then we'll return the data end plus 1. So that's kind of the value we're going to return from this logic check. And then what we can do is just check if this is equal to data start. So the thinking here is if we wrap around or not and we collide with our data start pointer, then we know we're at a full buffer. So we won't add the data to that buffer. Before I forget, let us add the pointer references. Okay. All right. So that's a good start. We can test this right now. We can do RB ring buffer, and then we can do not std, printf is empty. We'll just return it as a integer. 1 will be true, 0 will be false. Is empty pointer to the ring buffer. Oh, not RB, ring buffer. Cool. And then we can do the same for is full. And check it here. Okay. Return 0. All right. Let's compile. Ooh. Valid. Buffer size does not use, or preprocess does not use that. Unknown type RB. Am I messing up the syntax for a struct in C? Is it just freaking out over this? Struct. Okay. Whoa, 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 whoa. Uh-oh. Okay, that's saved. Expected colon comma. Hang on 1 second. I thought this was going to be as simple as going into those pointers and populating. Oh, we can't. Okay. we can't automatically assign. So we have to have an init essentially. So yeah, this will be easier in no, this will be much easier to do in um, in C++ with a constructor, but I just want to get the logic out here. So we'll have a void rb init, pass in the ring buffer pointer. Ring buffer pointer star rb. Okay. And then we'll have rb point to buff start is going to equal the pointer to the buffer. Our buff end is going to equal buffer plus buffer size. And then our data end will equal our buff start. And same with our data start. Okay. So we'll have our ring buffer, then we'll call rb init to populate it. We'll just pass in star of ring buffer. Okay. Now we should be good. Unknown type rb. I didn't type def. I did not type def it. Useless storage class specifier and empty declaration. Should I just put... Let me just put the alias on the bottom. There we go. Unknown type bool. So we need include std int.h and bool. Okay. Storage size of ring buffer isn't known. Struct rb ring buffer. Oh my gosh. I'm sorry, y'all. I made this more confusing. Obviously, we're passing in the address of our ring buffer. Golly. Alright. Okay. Now we can test. Is empty is true, is full is false. Alright. So, now we can add our write. This can either return a void or a boolean. We'll do a boolean. So we want to write a value, and we also want to have that value in here, where we just want data. So what we'll have to do is first check if it's full. Is full of RB. If that's true, we return false. And then if not, let me move this really quick. Cool. Cool. All right. If it's full, we're not going to do anything. But if it's not, if it's not full, we're going to populate the gosh, why am I blanking? We're going to populate where the current, hang on, I need to look at something. We're going to populate where data end is looking to. So the value at data end is going to equal data. And then we want to increment data end where it's either going to be RB data end plus 1 greater than RB.2 data or buffer end. Then we will check greater than or no. If it's equal to, if it's equal to the buffer end, yes, we'll need the same here. How am I on time? I have 15 minutes. Okay. So that's our condition. If that's equal to the end. If it is, then we return the data, or not data start, we return buffer start. And if it's not, then we just return data end. Gosh, stop doing that. Plus 1. Okay, and then we'll just return true. Okay, now we have write, and read is almost the exact same as far as the interactions, but with the other buffer. So we want to read, our data pointer will, or our data will now be a pointer because we're populating. Here we just want to check is empty instead, and then we do the we kind of just reverse this. So the value at the data address is going to equal the value at RB.2 data start. And then we'll do, this is almost the exact same as well. We just do RB data start equals RB data start plus 1, buffer end either does buffer start or data start plus 1. Cool. Okay. There's no other APIs we need to make here, but I think I have an existing test case where I can kind of just pass these in. So I think let's do that. I might need to change these names, but okay. Oh, geez. Well, we already know it's starting that way. We can tab that. And then, for the sake of simplicity, let's just do RB. So we'll write 5. Okay, yes, this is what we want. We'll first write 5 values. So the buffer will be full. And then, so here we can check printf is full, question mark, %d, and then we'll look at is full RB. Okay. And then we'll read 3, so we'll consume 3, and then we'll write 4, and then all remaining. Okay. Cool. Let's run it. All right. Oh, RB writes. The names are different. And cool. We should be good. Or not. Passing argument 2 of read, incompatible pointer type. That's because because we're using a uint8. Okay, fair enough. It's an int. RB is empty. Cool. All right. So it's full at 1. So let's run through this. So we'll have how do I oh, so I can just do this. What's the shortcut for it? Anyways, all right. So we're gonna have 10, 11, 12, 13, 14. And this is our full buffer. And then we'll have, because we know it's full, that passes. And then we will read 3. So this will get read. This will get read. And a third will get read. So we're going to have these 3 get read. So now our start is going to point here. And our end, actually, because it's full, our end points to here. Okay. So we pretty much have 3 empty slots. So that's gone, and that's gone. And I believe that's the behavior we saw. 11, 12. Wait, 10, 11, 12, 13. Hang on. Is something bugged here? Is it reading more? Oh, didn't add a semicolon. Okay. Okay, I'm not crazy. All right. So then we will write 4 more bytes. So, okay. So this is the interesting part. So if we printed the right return from this, we'd have this first one. This first one is going to be 20. Then 21. And then 22. 23 isn't going to be able to write. And neither, yeah, 20. So 23 tries to write here, but it's full, so it can't. Womp womp. So we will have what it will read out as when we dump the rest of the bytes is 13, 14, 20, 21, 22. And that is exactly not the behavior that we see. Where's 14? 14 should be there. I want a sanity check. Oh. Dang it. Okay. So this should read 10 through 14. Oh my gosh. I do not have that much time. Okay, we have a bug to fix here. Let's see if we can find it really quick. So, is empty? Yeah, that's fine. Is full? RB point data n plus 1 equals buffer end. It could just be not reading this parentheses right, which I can imagine. Buffer start data n plus 1 equals data start. Yep. Then right, we have that data. Yeah, that's right. Okay, and then start with the same update pattern. However, we might want to add this. Data start plus 1 or buffer start. We have a buffer. Buffer end, data start, data end. Yeah, okay. It might have been the ternary operator syntax was a little off because of the parentheses. No, it's not. Okay, let's walk through this. We write 5 bytes. So we write there is full is true. And then read should, that's the part I don't understand, is we're pointing to the same location. And then it just reads 13, 13, 13. So I think we're off somewhere. Maybe here? On our right? Not there. There. Huh. Okay, well, we have a bug to fix. But unfortunately, I'm out of time. It's really flustering me. Anyways, I have to go right now, but obviously this is a good starting point. We pretty much have this wrapped up. Well, a little PO'd that that isn't working. My only thing is that buffer size might account for -1. But I don't know. Anyways, I am going to commit this and I need to go. All right, see ya.